Yes, all of you can see the screen.
Yes, ma'am.
So these were the last time's expression asked for homework. Tried? Anybody tried this? Yes or no? Please give me the response. First question, there k less than 0, k greater than or equal to 0. The sequence values are 3 raised to k, 2 raised to k. And whose answer you have to just use the derivation of a raised to k transformed answer. And in that you have to just put the value for a. That's it. Done or not? Anybody?
No, ma'am. Can we solve it here?
One at a time, just unmute and tell me. I'm not able to hear you. So for this term, you have to use the Z transform of e raised to k and k greater than or equal to k less than 0. That transformed answer, in which a is replaced by 3. In the second term, this is Z transform of a raised to k only, but for which k greater than or equal to 0, and there you put a is equal to 2. That's it. So that will be the answer for the Z transform of the entire sequence f of k. Okay, so I think all of you can get it with the help of this. Even I have sent you my recording also. In that we have done how to do the calculations for a raised to k. So with the help of that, just to simplify. So next time onwards, I'll keep it in mind. I'll give you only one example for homework. Will it be okay? Because I'm not getting the response from you. 3 at a time. Hardly it is taking actually 5 to 10 minutes, but I can understand you all are busy in other academic sessions somewhere else, as well as the gap between your previous graduation and this one is of course more, and considering that, certainly we will take as per your time. Okay, as per your comfort level, we will go ahead. So don't worry, but at least I require some response so that I can go ahead accordingly. Otherwise, this will be like one-way traffic. I'll be just teaching and you will be just attending the session and taking the notes. That will not work. So
Yes, ma'am, it is taking some time for solving the problems as we are really lost the connection of mathematics. That's why it is taking a lot of time for even simple problems also.
Okay, I completely understand your problem. Okay, but this is what, so now if suppose if you are not done in this one day, so today and tomorrow And next week till Thursday time is there. In that, the remaining 2 problems also you can go ahead. This is a simply you have to apply the formula for a raised to mod k wala. Okay.
Yes, ma'am.
And just put a is equal to 1 by 4. That's it. Only I had asked you about this one, which was a different expression, e raised to minus ak. So anybody, if anyone has solved, then come up with this and you can share your screen. Otherwise, I'll just tell you how to get the answer for this. Anyone has got the answer for this e raised to minus ak? Okay, let me do. So this is a z transform of e raised to minus ak you are calculating. By definition, this is summation of f of k and z raised to minus k from, now here the range is from 0 to infinity. So only that much you take it. Okay. And which is equivalent to Priyanka madam, can you mute yourself? Priyanka Garsole. Okay, so here we are getting the summation
for reference point of view and for study point of view, which book we have to refer?
Yes, I'll give you. Yes,
okay, okay.
I'll give you. Actually, I'm suggesting for everyone that is a Grewal's book. Everything is there. New edition, 42nd edition is there. So that is available online. Even H.K. Das book is there. That book I'll just send you through classroom. That is online copy. H.K. Das wali. And Grewal also, where Z transform, Fourier transform, Laplace. All 3 you can get it.
Which first one you said?
First one is Grewal. V.S. Grewal's higher engineering mathematics.
Higher engineering mathematics by Grewal.
And another is advanced engineering mathematics by H.K. Das.
Advanced engineering mathematics by H.K. Das. Okay, thank you.
So in this case also you can have the expression containing this is e raised to minus ak and z raised to minus k, and range for k is 0 to infinity. So this also you can just put it as a series. If you put k is equal to 0, your first term will be 1. If you put k is equal to 1, e raised to minus k, z raised to minus 1. If we put k is equal to 2, this is e raised to minus 2a into z raised to minus 2 and etc. the terms. Okay, positive k values will give you this type of the series. Or you can have this is e raised to e raised to az raised to minus 1 plus e raised to az raised to minus 2. Can I write like this? Can I write this series like this? I'm just taking the negative power outside the bracket.
Yes, ma'am.
And then what is this series expression? As again, I'm telling that geometric progression, binomial expression only are used in this Z transform. Here also you have to see the second term upon the first term, third term upon the second term ratio. If it remains a constant, then that becomes your geometric series. Okay. So in this case, e raised to az into this thing, either you can do, just wait a minute, again it is disconnected. Okay, so instead of this negative power, we will just take it because it is in the increasing power. If it is there, then this will be better. So we can have e raised to minus a z raised to minus 1 raised to 1. We will make it e raised to minus a z raised to minus 1 raised to 2. We will make it. Okay. Third term will be e raised to minus a z raised to minus 1 raised to cube. I can write it and like this. So that will be your series of increasing powers of e raised to minus a into z raised to minus 1, which is the geometric progression with common ratio. With common ratio what? E raised to minus a
minus
z raised to minus. Yes. Okay. And therefore, whose summation answer we know? This summation answer is what? Summation answer for the geometric series is a upon 1 minus r for mod r less than 1, where a is the first term, correct? A is the first term. What is the first term in this case? So that is 1. And r is the common ratio, which is e raised to minus a z raised to minus 1. Therefore, our answer for the given Z transform of this e raised to minus ak is equal to 1 upon 1 minus e raised to minus a z raised to minus 1 for mod e raised to minus a z raised to minus 1 less than 1. That means you can take LCM. This term will go to the denominator and come with the numerator form. So e raised to az upon e raised to az minus 1. This is remaining. Correct, no? E raised to a upon z. This term will be coming into that form. 1 upon e raised to a into z. This is remaining into that particular form. Or for mod of this thing, it is mod of z. So if I take z on the other side, mod z will be greater than mod of e raised to minus a. That becomes our region of convergence. This is ROC, and this is the value for FZ. Okay, or this also can be written as Z upon Z minus e raised to minus a. Same thing from here. This is the same thing. If I take e raised to minus a as it is and only z raised to minus 1 को नीचे लिया, then it will be in that form. Okay, with this region of convergence. So just to know the z transform of e raised to minus ak, if it is a standard form and to be used in some examples, then directly you can make use of this z upon z minus e raised to minus a. Okay, now next we go to the fifth one or sixth one, whatever it is. F of k is equal to cosine function. Sine and cosine functions are there, for which the standard answer is calculated and which will be used in the example directly. Okay, so if f of k is equal to cos of alpha k for k greater than or equal to 0, only for causal sequence, find the z transform of cos alpha k. So what we will do, z transform of this cos alpha k is equal to, by definition, write the definition and connect it again.
Ma'am, if k becomes 0, then entire equation doesn't become 0.
Which one?
as you shown last step, f of k cos alpha into k, is it into k, alpha into k?
Alpha into k. Alpha is any scalar, non-zero scalar. K can start from 0. So if cos 0 is there, that will be 1.
1. Yeah.
So the series will start from 1 actually. Sequence will start from 1. So cos alpha k ka z transform is summation of cos alpha k into z raised to minus k and k from 0 to infinity. Okay. Now here one thing all of you have to recollect, those who have studied the complex numbers. Yes, please mute all of you. Okay. So here we are using some complex number property for the cosine and sine function. If somebody can remember what is cos theta in terms of exponential form, the complex number, what is sine theta in the exponential form, the complex number. Anybody can remember what is e raised to I theta? The people from electrical background may be using that again and again. What is e raised to I theta?
Cos theta plus I sin theta.
Yes, cos theta plus I sin theta. This is the complex number form. Okay, and e raised to I theta is actually the Euler's formula, which is presenting a complex number in the cosine and the sine function, cos theta plus I sin theta. So in this case, if I use the expression e raised to I theta plus e raised to minus I theta upon 2, I'm going to get the answer as cos theta. So this is e raised to I theta answer, and e raised to minus I theta answer is cos theta minus I sin theta. And if you add them, then we will be getting the answer as cos theta, 2 cos theta. So we will be using this cosine formula. In place of cos alpha k, now we will be using this exponential term. Okay, therefore z transform cos alpha k is equal to summation of this. Now how you will write cos alpha k in the exponential form? How you will write cos alpha k in the exponential form? Anyone? Cos theta, if it is there, then we are writing e raised to I theta. I want cos alpha k. So e raised to what you will write?
E raised to I alpha k.
I alpha k.
Correct. Minus, sorry, plus e raised to
minus I alpha k
upon 2
divided by 2.
Yes, very good. So that is the cosine form in the exponential term. Okay, and k is of course 0 to infinity. So e raised to I alpha k plus e raised to minus I alpha k into z raised to minus k. Now you do the next thing is the separation of this summation into two parts. So I can take 1/2 common outside the summation sign. First sum is on e raised to I alpha k, z raised to minus k. And second summation is for e raised to minus I alpha k into z raised to minus k. Both cases, k is of course 0 to infinity. And 1/2 is for both. Okay, so I can put it in the square bracket. So e raised to I alpha k, z raised to minus 1 is minus k, and this one. So again, that can be rearranged.
Too much background sound is coming.
Yes, yes. Yes. So we'll go ahead with this now. This is e raised to summation of e raised to I alpha multiplied by z raised to minus 1 raised to power k I can write. Plus second summation I can write it as e raised to minus I alpha z raised to minus 1 raised to power k, and k from 0 to infinity. Okay. I have not done anything new. This is just rearranging the terms in the form of the power of k. Okay. And as you can see once again, if you put k is equal to 0 in both the summations, they are forming again the geometric series. So if I put k is equal to 0 here, the first term is 1. Okay. Second term k is equal to 1 means e raised to I alpha z raised to minus 1. Then e raised to I alpha z raised to minus 1 square and etc. First bracket plus second bracket I can write, putting k is equal to 0 once again we'll get 1 plus k is equal to 1 if you put e raised to minus I alpha z raised to minus 1, then e raised to minus I alpha z raised to minus 1 square and etc. That is your second term. And everything outside 1 by 2. Okay. Are you getting? I'm not doing anything new. This is just I'm putting the k values 0, 1, 2, 3, etc. I'm writing the series. And this series, both the series are therefore the geometric progression, are the geometric series with first term में common ratio is e raised to I alpha z raised to minus 1, and second term common ratio is e raised to minus I alpha z raised to minus 1. Okay, this is the common ratio. Here it is the common ratio r, and therefore we'll get the answer for this is 1 upon 2. First series answer a is 1 upon 1 minus r, that is e raised to I alpha z raised to minus 1, plus second series also 1 upon 1 minus e raised to minus I alpha z raised to minus 1. Are you getting? Geometric series, the answer is this one, and that too for the region of convergence. In the first case it is mod of e raised to I alpha z raised to minus 1 less than 1. In the second case this is mod of e raised to minus I alpha z raised to minus 1 less than 1. That is the region of convergence. So actually this is the answer for the cosine alpha k expression, but still in the denominator I'm getting the complex number e raised to I alpha. Okay, so to reduce that particular expression, once again simplification done, and again we are substituting the original value for e raised to I alpha and putting it into the standard form. So this is 1 upon 2. Now take first of all the calculation by taking the LCM in the denominator. Okay, so this is 1 minus e raised to minus I alpha z raised to minus 1 plus 1 minus e raised to I alpha z raised to minus 1 upon these two brackets multiplication. This is LCM. 1 minus e raised to minus I alpha z raised to minus 1. This is the multiplication in the denominator. Okay, and this will become therefore 1 plus 1 is 2 numerator, this one and this one is 2, and remaining term you can put it as minus e raised to I alpha minus e raised to I alpha and plus e raised to minus I alpha, this is into z raised to minus 1 upon, now denominator if you simplify, it is the two brackets multiplication. So 1 into 1 is 1, then this term into this term, e raised to I alpha z raised to minus 1 into e raised to minus I alpha z raised to minus 1. That multiplication is nothing but how much it will come? E raised to I alpha into e raised to minus I alpha. What is the multiplication? No? What do you get for these two terms?
1 minus
Plus e raised to I alpha into e raised to minus I alpha means indices का
e
addition
raised
होता है.
to 0.
E raised to 0
0
is 1 and z raised to
is
minus
1 and z raised to minus 2.
yes, so this is z raised to minus 2. That's correct. And the middle term you have to write down. Okay, so middle term which will be minus e raised to I alpha z raised to minus 1 because this and this multiplication. 1 into this and another 1 into the second middle. This one and this one multiplied, giving you minus e raised to minus I alpha.
Minus e raised to minus alpha z raised to minus 1.
Yes, I think you can understand. Okay, now this one. So this is your complete denominator expression. Okay, so that is happening on the denominator. Numerator term will be as it is. Now you can just club the terms and wherever possible, write down e raised to I alpha plus e raised to minus I alpha is equal to 2 cos alpha. What do you get? This is 1 by 2 and 2 into bracket. What I can write down for this term? In the form of cosine function, e raised to I alpha plus e raised to minus I alpha. What I can write? Like here I have written cos theta is equal to this one. ये लिखा था ना cos theta. So if theta के बदले alpha है, तो what do you get? Same thing, no? Here it is
2
coming.
cos alpha. 2 cos alpha.
Minus
2
2.
cos alpha.
Yes, so this is
2
just minus
cos
2
alpha
cos.
z raised to minus 1.
Yes, z raised to minus 1 for this one. Okay, z raised to minus 1 upon same thing denominator में I can take again common from this z raised to minus 1. So I can write down this as z raised to minus 2 minus z raised to minus 1 into this is e raised to I alpha minus sign I have taken it common e raised to minus I alpha plus e raised to minus
Plus
I.
e raised to minus alpha.
Again, that can be replaced by a cosine function. What is that? It's 2 minus 2 cos alpha into z raised to minus 1 upon 1 plus z raised to minus 2 minus z raised to minus 1 into bracket. What do you write? E raised to I alpha plus e raised to minus I alpha is
2 cos
2
alpha.
cos alpha.
2 cos alpha once again. Okay, so everything is now replaced in the form of cosine function. And there, this 2 and 2 is getting cancelled. Numerator with 2 is there as a multiple. Denominator with 2, it is getting cancelled. And therefore, we get the answer as, now for this, now z raised to minus 1 means 1 upon z. Correct? So this is like 1 upon z. So that z will come here and we'll get z minus cos alpha upon, this is denominator, we can write down. You can again take z raised to minus 2 means 1 upon z square. Z raised to minus means 1 means 1 upon z. So LCM again will be z square. So it will come out as z square minus 2z cos alpha and plus 1 upon z square. Okay, if you simplify with this LCM as z square, then we will get this term z square minus 2z cos alpha plus 1 divided by z square. So actually this is the answer for z transform of the cos alpha k. Therefore, finally we are getting the result for this as z transform of cos alpha k is equal to z minus cos alpha k. And this is one more term is missing in the numerator. Numerator में 1 upon z is also there, no? So that I have not written upon z. Okay, z minus cos alpha upon z in the numerator divided by z square minus 2z cos alpha plus 1 upon z square in the denominator. So this square वाला एक z इसके साथ cancel हो रहा है numerator के साथ. And we are going to get this z will come to the numerator and we'll get z into bracket z minus cos alpha upon z square minus 2z cos alpha plus 1. That is actually the cosine transform, z transform of the cosine function cos of alpha k. Now here one more thing we have not calculated, so that also let us see. This is just the answer in the form of fz we got. This is your answer for fz. But what about the region of convergence? So here the region of convergence, we are getting it into these two forms. ये दो forms है. Okay. So that also we will just simplify and get one particular expression where the region of convergence is this mod of e raised to I alpha z raised to minus 1 less than 1. So one expression we will just simplify. So what happens, since e raised to I alpha is cos alpha plus I sin alpha. Okay. So since e raised to I alpha is cos alpha plus I sin alpha, therefore mod of e raised to I alpha. What I am getting, e raised to mod of e raised to I alpha. Modulus का meaning क्या है? It is under the square root sign cos square alpha plus sin square alpha. Is this correct? Modulus of z or anything magnitude, matlab under the square root sign, real part square plus imaginary part square. So cos square alpha plus sin square alpha. And what is this identity? Cos square alpha plus sin square alpha?
1.
This is 1. So we will be getting this e raised to I alpha modulus is 1. Okay. Similarly, if you take e raised to minus I alpha, that is also giving same thing, under root cos square alpha plus sin square alpha, that is 1. Because minus में कुछ फर्क नहीं है, because sign negative is if you square it, that becomes a positive. So we'll get the answer as equal to 1 here, and e raised to I alpha modulus is also 1. Therefore, this expression e raised to mod of e raised to I alpha z raised to minus 1 less than 1 implies mod of e raised to I alpha, that 1 upon z will go to the other side and it will come here, mod z, correct? Or just now we have seen e raised to I alpha ka answer, modulus answer is 1. So that means 1 is less than mod z, or which implies mod z is greater than 1. Are you getting? This is the region of convergence for this one. The region of convergence. E raised to I alpha z raised to minus 1 less than 1 means mod z greater than 1. And similarly, mod of e raised to minus I alpha into z raised to minus 1 less than 1 implies what it will be? Can you guess? What it will be? Will it be the same? Will it be same or different? Yes or no? What is e raised to minus I alpha? That means mod of e raised to minus I alpha less than mod z. And what is this modulus just now we have calculated? This is equal to 1. Right? This answer is 1, which is less than mod z. So once again, same meaning. That means mod z is greater than 1. So both are same region of convergence. And this is the answer for fz. Final answer. So you can write down lastly, therefore, this is the last form which you can remember. Z transform of cos of alpha k is equal to z into bracket z minus cos alpha upon z square minus 2z cos alpha plus 1 with region of convergence as modulus of z greater than 1. This is only for the causal sequence. Okay? Are you following or not?
Yes, ma'am.
Yeah. So please write, because those who have still not understood, please go through the procedure, whatever we have done it here. But ultimately, you are not going to derive anything. Derivation is just for your understanding. I have given it here, how the answer is coming. But you can remember only the last form, this one, z into z minus cos alpha upon z square minus 2z cos alpha plus 1. And the region of convergence is mod z greater than 1. So in general, suppose the example is, for example, suppose z transform of cos of 3k it is asked. Then we will write down alpha is equal to 3. That's it. So minus cos 3 upon z square minus 2z cos 3 plus 1 for mod z greater than 1. Okay. Are you following?
Yes, ma'am. Just a minute.
Yes. This last form is important, which you have to write it, and that way we have to simplify. Similarly, we can find out the answer for sine alpha k. So that I will leave it to you. Derivation, if you are interested, then you can go ahead with the same form, whatever we have done it for the cosine function. Sirf exponential form is different, that you have to consider and simplify. Okay. So you are interested in the final value. What is the function of z? That only is important. So next form as such, you can write down next standard result. Seventh one, z transform of sine alpha k. Z transform of sine alpha k. I'll give you here the result. You try it at home just for your interest. You can try the answer and get the value as equal to z sine alpha अपॉन z, डिनोमिनेटर दोनों का सेम है, z square minus 2z cos alpha plus 1 for region of convergence mod z greater than 1. Only numerator is different for sine functions. Using e raised to I alpha k minus e raised to minus I alpha k upon 2i is equal to sine alpha k. Use this form and simplify. Okay, those who are interested, I'm telling again and again, because derivations are, nobody is going to ask you the derivation as such, only how the answer you are using while solving your problems. That is the important part. Okay, so z sine alpha upon z square minus 2z cos alpha plus 1, that is the sine answer, and modulus of z is given by the region of convergence. Priyanka madam, please mute yourself.
Yes, ma'am.
Yeah.
Okay.
Hello,
madam.
Madam,
if we don't need to means, ma'am, we don't need to remember the derivation, right? If we means if we only remember the final values, final equation, will it be okay, ma'am?
Yes, that is what I'm telling. But lot of things we have to remember. So suppose if in any case, if you don't remember a standard particular form, then how the answer is coming, for that I am showing you the method. This way you can go ahead and get the result. Okay. Suppose in case if you
Yes,
don't
ma'am.
remember the formula, then you should know how to get the answer for that transform. So that is the procedure. Okay. So this is for
Yes,
sine
ma'am.
and cosine function. And with the hyperbolic function, there are two forms, sine hyperbolic and cosine hyperbolic. Again, with the similar form, it is calculated and got the answer for this FZ. So that also you can directly put it the result, eighth result as such you can have if f of k is equal to cos hyperbolic function form alpha k and k greater than 0. K greater than equal 0, that causal sequence. So using now like complex numbers, how we have used, similarly the hyperbolic functions have the formula cos hyperbolic alpha k, you can use this form, e raised to alpha k plus e raised to minus alpha k divided by 2. No I in this case, please write carefully. So cos hyperbolic alpha k is this one, and using this definition and simplifying the series, geometric progression you will get, and again the summation, which will give you the answer for.
Madam, after it, is there double F?
Which one?
After 8 number, there is a double F, F of K. Previous, just before F of K, it is if, okay.
If it is, if f of k is equal to. So z transform cos of hyperbolic function alpha k, which will come out as z into bracket z minus cos hyperbolic alpha divided by z square minus 2z cos hyperbolic alpha plus 1. Okay, and here the region of convergence is given as mod z greater than maximum of e raised to mod alpha or e raised to minus mod alpha. Okay, with e raised to alpha in the modulus sign and e raised to minus alpha in the modulus sign. So maximum of that means what? Because here it is not a complex number. So e raised to alpha means exponential term. It is increasing. So दोनों में से maximum कौन सा है? That is your answer for modulus of z greater than. Okay, so that is to be considered. Only you can just remember cos hyperbolic alpha k and ninth result for the sine hyperbolic function. So z transform sine hyperbolic alpha k for k greater than or equal to 0. Once again, it is giving you z sine hyperbolic alpha divided by z square minus 2z cos hyperbolic alpha plus 1. Denominator दोनों का same है and the region is also same. Or mod z greater than maximum of mod e raised to alpha or e raised to minus alpha. Okay, so that can be remembered as a standard form for this particular function. So as an example, I'll just take the example for this sine and cosine function also, how it can be used in the expression containing the trigonometric terms. Okay. Suppose question is asked to find the z transform of cos of 3k plus 2. Suppose find z transform of cos of 3k plus 2, k greater than or equal to 0. Actually, here there is not only the cos 3k term, but along with the plus 2 is also there. So before going to the standard formula, we have to first of all use the cosine function identity, trigonometric identity. So if anybody can remember cos of a plus b formula, we can use that. Cos a plus b, किसी को मालूम है what is written as a standard result trigonometric identity? No. So this is cos a cos b minus sin a sin b. Okay, this is a standard trigonometric identity. So here, who are asked cos of 3k plus 2. So a is 3k and b is 2. That means cos of 3k cos 2 minus sin 3k sin 2. Right? And of course, cos 2 and sin 2 are the constant terms. They will give you some constant angle value. Okay. So only you need to calculate the z transform of this cos 3k and z transform of sin 3k. Therefore, z transform of cos of 3k plus 2 is nothing but Z transform of cos of 3k. Okay, in that case, cos 2 will be constant. I'll write it here. No need to take it under the transformation. Transform kiska hoga? Only for the kth sequence. So cos 3k is the sequence for which the transform we are doing, minus sine 2 is constant, Z transform of sine 3k. Are you getting? Yes or no?
Yes, madam.
Yeah. And therefore here cos 2 is remaining constant. What I should write? Cos 3k answer. Just see what you have written and tell me here. What I should write? Cos 3k. No, you have written no cos of alpha k answer. Alpha is 3 here.
Z minus cos 3
cos 3k
divided by Z whole divided by Z square minus 2Z cos 3 plus 1 divided by Z square.
Correct. Very good. So Z into bracket Z minus cos 3 numerator upon Z square minus 2Z cos 3 plus 1. That's the denominator, which is the answer for cos 3k, minus sine 2 as it is, and sine 3k transformation, the sine alpha k ka answer you are using. That is, what is the answer for sine?
Sin alpha
Hmm?
divided by Z square minus 2Z cos alpha plus 1.
Numerator you are getting it as?
Z sin alpha.
Yes, so Z sine 3. Correct? Z sine 3
Yes,
upon
ma'am.
denominator same, 2Z cos 3 plus 1. It remains same. Okay. And of course, here the region of convergence is remaining same, that is mod Z greater than or equal to, sorry, mod Z greater than 1. That is the region of convergence. So cos 2 into this form plus sine minus sine 2 into this particular expression. No need to club or simplify once again, just it is required to get the answer in the form of FZ term. Okay. Okay, so we'll go ahead with this. This is just a simplification which I would wanted to tell you that this will happen for the cosine of the sine function. Okay, and one more result for this, we will just add it here for the combination term, that is NCR sequence, or it is like a no combination. N elements may say R you have to choose, for which we are calculating the answer for this. So this is the NCK. So next 10th result as such you can put it here. If f of k is equal to NCK, this is a sequence for 0 less than equal to k less than equal to n, then Z transform of this sequence f of k, which is nothing but summation NCK Z raised to minus k and k from 0 to n. It's a finite term we are taking. Okay. K is from 0 to, you can take it up to infinity because it is given 0 to n for that particular combination. So here you can take it like infinity and consider, means the series will be convergent series. So here we are getting for k is equal to 0, if you put, that gives you NC 0. If you put k is equal to 1, NC1 Z raised to minus 1. If you put N K is equal to 2, this is a NC2 Z raised to minus 2 and etc. the terms. Okay, so as you can see, this is nothing but a binomial expansion. What is NC0? NC0 means what? You know this meaning, NCR, n factorial upon n minus r factorial into r factorial. This is the formula for the combination. So when you are having NC0, your answer will be 1. Correct? If we put NC1, the answer will be n. If you put NC2, the answer is n into n minus 1 upon 2 factorial, z raised to minus 2, and etc. And this is standard binomial expansion of 1 plus z raised to minus 1 raised to n. Simplify this binomial expansion, getting this is series. This is binomial expansion of 1 plus z raised to minus 1 raised to n, and that is always convergent for mod z greater than 0. Therefore, z transform of nck is equal to 1 plus z raised to minus 1 raised to n for mod z greater than 0. Answer only you can remember, which is nothing but 1 plus z raised to minus 1 raised to power n. Okay, so simplification is with that particular form where we are getting this as the binomial expansion, and with that we are going to solve our equations. Okay, so after this actually there are the properties which I would like to give you, but not today immediately. In the next week we'll go to the properties and then simplify the examples. By the time these examples, out of that one or two, we will just solve it here, and I'll give you one example only for homework. Okay, at least to try with the help of what we have done today. Based on that, we will take the solution. So take down this one, find Z transform of whatever the sequences you have studied. With that, we will calculate. So as an example, if f of k is equal to sine of k pi by 4 plus alpha for k greater than or equal to 0, find it's a Z transform. Find the transform of f of k. Okay, so how will you proceed for this? Again, we will be using the first of all trigonometric identity for the sine function, and then apply the Z transform result. So can anybody tell me what is sine of a plus b? What is sine of a plus b? No? Is this correct? Sin A into cos B plus cos A into sin B. Yes or no?
Yes, madam.
You were doing no before. Already you have used. This is a basic trigonometry in the 10th and 11th standard, where trigonometry introduction is there, where you are having the initial properties or the identities of the trigonometric function. So in this case, therefore, sine of k pi by 4 plus alpha. Just find out. Yes. So find out what is sine of k pi by 4 plus alpha. That is sine of a means k pi by 4 into cos alpha plus cos of k pi by 4 into sine alpha. Correct, no?
Yes, ma'am.
And there we are cos alpha and sine alpha is of course the constant terms. Okay, no k in that. That means it's not a sequence. So we are taking the outside the transformed expression. Therefore, Z transform of sine of k pi by 4 plus alpha is equal to cos alpha, keep it outside. Take only Z transform of sine k pi by 4 plus sine alpha, keep it outside, and Z transform of cos k pi by 4. Correct? Now just write down the formula and tell me what is your answer. Sine k pi by 4 means sine alpha k ka answer all of you know. Cos alpha k ka answer you have written. Just put alpha value there and tell me what is this Z transform.
Madam, it is cos alpha into z sin pi by 4 divided by z square minus 2z cos pi by 4 plus 1. And second is sin alpha into z minus cos pi by 4 divided by z square minus 2z cos pi by 4 plus 1.
Yes, very good. But here further also you can put the value. You know sin pi by 4, cos pi by 4 answers. What is that?
Okay.
What is sin pi by 4 and cos pi by 4? (45°). Now this thing 1 upon root 2. Put it here. And that will be the final value. Cos alpha z upon root 2 divided by z square minus 2z upon root 2 plus 1 plus sin alpha z into bracket z minus 1 by root 2 upon same denominator, z square minus 2z upon root 2 plus 1. Okay.
Madam.
So if you are keeping as it is, no difficulty, just keep it as it is. Otherwise, you can have the simplification z minus 1 by root 2 and cos of alpha z. This is first term, cos of alpha z into z first term upon 1 by root 2. Okay, so this is cos of alpha z into yes, z upon root 2 actually it is. Z divided by root 2 upon, this is root 2, one of the root 2 is getting cancelled with this. Numerator is coming out as root 2. So this is z square minus root 2z plus 1. At second term multiplied by plus cos alpha, of course we have done, and plus z sine alpha, second term z sine alpha into z minus 1 by root 2 divided by z square minus root 2z plus 1. For the region of convergence is mod z greater than 1. Hello.
Yes, ma'am.
Hello.
Yes, ma'am. Yes, ma'am, you are audible.
रमा मैडम मारू गया
Yes, yes. In between there was a call for me. Sorry. So I think this is clear. This problem is clear. Whatever we have done today on the cosine and sine function, if the questions are like that, you have to just get the transformed answer into this pattern and simplify for this fz. Okay. So likewise, these are few expressions which I would like to, not few, I will give you only one, okay, restriction for me. So that one example, at least you can try and get it next time as a solution. And I have to take now the properties behind this transformation. So with the help of those properties in our next lecture, we are going to solve. And the last part, that is the inverse calculation. So by next week, of course, I'll be giving you the sufficient part of this Z transforms, and then we can go to study the next transformation, okay, with the help of this. So as the homework, you can try this one. If f of k is equal to cos of k pi by 4, sorry, k pi by 2 plus pi by 4. If this is a function for k greater than or equal to 0, find the transform f of k. Okay. आज जो किया उसका है same. Only you have to write trigonometric formula and then apply the Z transform. You will do. Yes or no? Did you do this problem?
Yes, ma'am.
yes madam
Yeah, only one I'm giving. So now I don't want any excuses next week. Okay, because we are meeting on Thursday, next Thursday. So by the time, just revise the part, whatever we have done from the beginning. Definition of set transform, standard sequences and geometric series, फिर उसका summation. इतना याद रखा तो भी चलेगा. And I'll be sending you or uploading the class study material for in which you are having the Z transforms ke formulae, basic formulae, and the questions which I am showing you as every time, that is a PDF, that also I'll be uploading. So in that also many examples are solved. So please go through that, and this recording also I will upload it. Okay. So those who were not there in this, at least you can take the benefit of that and do the problems. But just a minute, I'll take your attendance.
Ma'am, can you share syllabus also?
Yes, yes. It is already there, I think, on the website. It's not there?
No, we did not check on website.
Okay, I'll give. Yes, so we'll meet in next week, Thursday. By the time, see you then. Goodbye.
Bye, ma'am.
Thank you, ma'am.
Thank you, madam.
Thank you, ma'am.
Thank you, ma'am. Bye.
Yeah, welcome.
Thank you, ma'am.